Hello and welcome. This is Edexcel iGCSE Computer Science. This is a 2020 paper. Paper 1, the theory paper, Principles of Computer Science. A 2-hour paper was done in November of 2020. There's some details here about filling it in. I've linked to it in the description, and total marks are out of 80. So for this exam, there's 2 papers, paper 1 and paper 2, both 80 marks, and your total mark will be out of 160. The paper 2 is the practical paper where there's more Python programming. In this paper, it is just theory, there is no programming. So let's start with question 1. A peaker manages the network in her office building. A peaker uses the network to install software updates on all the office computers. Give 2 other reasons why the computers are connected into the network. So they're connected to the network because we want to share data, want to share resources. So the first one is to share resources, for example, a printer. And the second point I made there is to share an internet connection. So we'll scroll down and look at B. The network uses wired and wireless connectivity. State 2 advantages of using wired rather than wireless connectivity. Okay, so with a wired connection, there is a better connection because it does not get obstructed by walls, ceilings, furniture. The connection doesn't have to go through walls, ceilings, furniture. It's literally direct. So that's the first point I'm going to make here. So the connection is stronger because it does not have to go through walls and doors. And the second point I'm going to make is that it is more secure. It's more secure because it's less likely to be intercepted, which could be a problem with wireless. Number 2, state 2 disadvantages of using wired rather than wireless connectivity. The problem you've got really is it's more complex to install. So that's going to be my first point that I make. So that complexity of installation means it costs more. And the second point I'm going to make is that there are health and safety issues from the wires. So the second point I made there is there are health and safety issues from tripping over wires. C. Some people confuse the term Internet and World Wide Web. Describe the difference between the two. Well, the Internet is the network and the World Wide Web are the web pages. So let's construct an answer. So my answer here says the Internet is a global network, whereas the World Wide Web is a collection of web pages that are accessed on the network. D. Networks use both IPv4 and IPv6 addresses to identify connected devices. Explain why IPv6 addressing was introduced. Well, quite simply, it was introduced because we ran out of IPv4 addresses. So IPv6 was introduced because we ran out of IPv4 addresses as the internet has grown and more devices require IP addresses. E. Networks layouts can be based on a number of different network topologies. Figure 1 shows the network topology. State the name of this topology. It is, of course, a star. State 1 benefit of using the star topology. So the benefit of that. Main benefit, easy to connect new nodes. Just 1 mark there, so not writing a lot. It's easy to connect 1 node. Drawback of using this topology. Well, if the central switch fails or hub fails, then the whole network goes down. The whole network stops working. F. The network uses TCP/IP. Figure 2 shows the TCP/IP protocol stack, application transport network data link layer. One of the application layers is to send and receive emails. State 2 email protocols. There are actually 3. I'm going to choose SMTP and IMAP. You could have POP3 there as well. 2. Upeka sends an email to Peter. The transport layer in Upeka's computer splits the email into data packets. State 2 tasks were performed by the transport layer in Peter's computer when the packets arrive from the network layer. Right, when it comes back from the network layer, you check if all the packets have arrived. So it checks if all the packets have arrived. Then it reassembles the packets into the correct order. So it reassembles the packets into the correct order. And that completes question 1. Question 2. Computers use binary digits to represent data. A. Sign and magnitude uses two's complement are ways of representing signed integer numbers. Convert the denary number -94 to a binary pattern using sign and magnitude representation. Now, for this, we need the place values 1, 2, 8, 64, 32, 16, 8, 4, 2 and 1. And what we need to do is take the first value there, 128, that needs to be a 1. So that needs to be a 1 because it represents a negative number. If that was 0, it would represent a positive number. So now what I'm going to do is create 94 from these values. So I need a 64, okay. I don't need a 32 because that would give me 96. And remember, we're doing this without a calculator. So I need a 16, that brings me to 80. Then I'll take that 8, that brings me to 88. Then I'll take the 4, that brings me to 92. And I'll take the 2, that brings me to negative, that brings me to 94. And because I placed the 1 there at the beginning, that is negative 94. So the answer then is 1101, 1110, and that's 2 marks. 2, 10001001 is a signed integer that uses 2's complement representation. Convert this signed integer to denary. So the first thing I do is I write all the bits down and make sure that I just tidy it up. Perhaps I just move that across a bit there. Okay. So remember, to do 2's complement, we flip the bits and add 1. So first thing I'm going to do is flip the bits. So flipping the bits means that zeros become 1s and 1s become 0s. So you can see through here each column 1s become 0s and 0s become 1. Then the next step is I add 1. So here we can see that I've added 1 because in place value 1 there, I've simply placed a 1 to add 1. Now all I need to do is add them up. So 64 plus 32 is 96, plus 16 is 112, plus 4 is 116, plus 2 is 118, plus 1 is 119. So the answer there is 119. Now, because it is a signed integer, it needs to be negative 119. B. Denary numbers use base 10. Identify the base for hexadecimal numbers. It is, of course, 16. C. Computers encode characters using ASCII and Unicode. Take the number of characters that can be represented using standard ASCII. It is 128, which includes a null character as well. You can get away with 127 there as well. 2. The ASCII system uses 7 bits to represent a character. The ASCII code for the character A using denary is 65. Other alphabetical characters follow on from the sequence. Identify the code for H. So if A is 65, you just simply got to count them on. So B will be 66, C will be 67, D 68, E 69, F 70, G 71 and H would make that 72. So the answer is C. So that is 64 plus 8, that's 72, and the correct answer is C. 3. Explain why Unicode was developed. Unicode was developed because we cannot represent all major languages using ASCII. So we cannot represent all major languages using ASCII. Unicode can represent all major languages. As it uses a minimum of 16 bits, and that completes question 2 for 9 marks. Question 3. The central processing unit, CPU, and other hardware components work together with the operating system to run programs and store data. Here is a partially completed diagram showing the hardware components used in the fetch, decode, execute cycle. The function of the I/O controller is to manage communication between the CPU and input-output devices. Complete the diagram by labeling the buses, adding directional arrows to show flow of communication. So there's 6 things we need to do here. So the first thing I'm going to start with is the buses, and at the top here I have the address bus. Then underneath that is the data bus. The control bus comes underneath that bus. Now let's look at the dotted lines. So there's some clues here that we need to look out for that are going to help us with this question. If we look at the keyboard controller, from the address bus, the directional flow is from the address bus up to the keyboard controller. Display controller there. The address bus, the data flows from the address bus up to the display controller. So the direction of travel is going to be that the arrow points upwards. So you can see here I've drawn as best as I can using the fill in sign. I've drawn the direction of arrow flowing upwards. You would need to make that a bit clearer in your exam, but that's the best I can do with the tools I've got here. So we need to look at the keyboard controller now. Now if we look at the display controller and RAM there, we can see that we've got bidirectional arrows. So it's going to be the same for the keyboard controller. So now you can see that I've got bidirectional arrows from keyboard controller down to the control bus, which matches the display controller and the RAM. The final one to do is the display. Now, if we think about this logically, a display is an output. So we would think that the data would flow from the display controller out to the display. Whereas if we look at the keyboard, it flows in from the keyboard to the keyboard controller because that's an input. So we're going to add an output to the display. So here we can see I've added the directional flow which goes from the display controller up to the display. And that completes that question for 6 marks. B. The CPU includes an area of cache memory. Increasing the size of the cache will improve the performance of the CPU. Explain how increasing the size of the cache improves the performance. Cache stores frequently used instructions. It is closer to the CPU. In the order of importance, the CPU comes first, followed by cache, and that is level 1, 2 and 3 cache, followed by RAM, followed by secondary storage like the hard drive. So the CPU will look for data first in the cache. If it isn't in cache, it will look in the RAM. If it isn't in RAM, it will look in the hard drive. So increasing the size of the cache will speed up my computer. So I'm going to write an answer now. Now, cache is definitely faster than RAM, and RAM is definitely faster than the hard drive in terms of processing data. So it speeds up processing because cache is a faster type of memory. It's definitely faster than RAM. And that is another 2 marks there. So go and look at C. Quite an interesting question. There's some computers have more than one CPU. The CPU will work in parallel to execute instructions. Complete the table to show how 2 CPUs working in parallel could execute the expression. And there's the expression there in bracketed. And we can see it's got some multiplication, which is done first, then division, which is done first, then addition and subtraction. So the first bit's been done for us. 5 times 2 equals 10. So we need to do the next bit. Okay, and simply we just take the brackets because remember, BIDMAS, we do the brackets next. 4 times 3 is equal to 12. So what's the next thing we need to do? Okay, well, the next part of the CPU will add those together. So 10 plus 12 equals 22. Now, it really doesn't matter which order you do these in. Maybe logically you should do 24 divided by 4 equals 6. Maybe that should be on the left-hand side. It doesn't really matter. You're still going to get marks as long as you do this correctly. So we've taken the brackets there and we've done the addition there. And finally, we need to do 22 minus 6 to do the subtraction. So 22 minus 6 equals to 16. And we didn't need to use all the rows there, all the columns. We just used 5. So that has completed the expression there. And that is the answer to that question. D. One function of an operating system is to manage files on secondary storage. Describe how an operating system manages the storage of a file on a random access secondary storage. So this is how does the operating system manage the storage usually on a hard drive? We're probably talking about a hard drive here. So what the operating system is going to do is check whether there's sufficient storage space. Then if there is, then the file is going to be broken into blocks. The blocks are stored in spaces that are large enough, and the FAT table will be then updated with this latest information. So let's construct an answer to that. Okay, the operating system checks whether sufficient space is available on the secondary storage for the file. The file is then broken into blocks. The blocks are stored in spaces that are large enough. The operating system updates the file allocation table, or FAT, and that is the answer to the question. And that completes question 3 for a total of 16 marks. Question 4. Ibrahim works in the music industry. He is learning how sound is represented in binary. Figure 3 illustrates the process. So here we've got figure 3, and we can see analog sound waves and digital representation. The analog sound waves are the curved sound waves there in the dotted line. Digital representation is represented with the squared off lines. And along the axis we've got amplitude and seconds. So on the y-axis we've got amplitude, and on the x-axis we've got seconds. State what the dotted line A represents. It represents the digital signal. So just be clear about that. Line A is the squared off line there, and that represents the digital signal. So represents the digital signal. State what the dashed line B represents. That represents the analog signal. So the dashed line represents the analog signal. Give the sampling frequency including the correct units. So the correct units are measured in hertz, samples per second. So we need to look at the seconds there. Along the x-axis we can see 1, 2, 3, 4, 5, 6, 7, 8. Now we can see that a sample has been taken every half second. So in a second there are 1, 2 samples being taken. So we can say that sampling rate is 2 hertz. So hertz is samples per second, and we've taken 2 per second, so the answer is it's 2 hertz. 4. Give one impact of increasing the sampling frequency. Well, we'll represent the file more accurately, but we'll also increase the file size. So we just need to choose one of those. So my answer for that is the sound will be represented more accurately. 5. The bit depth measures the resolution of the sound sample. State the minimum bit depth needed to store the sound sampled in figure 3. Justify your answer. Okay, let's go and look at that. So we just scroll up and look at this diagram. Now, you can see amplitude goes up to 7, but we only use up to 6 there. So, okay, the bit depth needed will be 3. So my justification is the range of sample sounds will be from 0 to 6. So 3 bits is needed to store all the data values. 000, 001, 010 for 2, 011 for 3, 100 for 4, etc. So we need 3 bits to store that. And then quite a nice question here for number 6. Give the value in binary of the audio sample at the 4th second. So let's go and have a look at that. Here we've got the 4th second, and we can see it's number 5. And so all we need to do is to convert 5 into binary, and the answer is 101. That ignores the leading 0 leading digit there. B. Ibrahim wants to store a music file. The sampling frequency is 47 kHz. The bit depth is 64. The analog signal lasts for 819 seconds. Construct an expression to show how the file size in bytes is calculated. You do not need to do the calculation, so you will not do the calculation. Don't even try. You're not going to get any marks for it, okay? So all we need to do is construct an expression. So remember, we'll write this down. So to get it into bits, it'll be rate times resolution times seconds. So we can remember it with the expression rate times res times sex there. Okay, so I need to do that calculation now. But I need to remember that it's 47 kilohertz. So it needs to be multiplied by 1000. So let's construct the expression now. So if I use that rate times res times sex, I've got 47,000. So it's 47 kilohertz times 64, which is the resolution, times 819. Then what I need to do is divide that by 8 to get it into bytes. If it was into kilobytes, it would need to then divide it by 1024 again. So I divide the lot by 8, and that would give me the answer in bytes. Let's go and scroll down and look at C, and this completes question 4. Ibrahim wants to upload a music file to his online storage. The file has been compressed using a lossy algorithm. Give one drawback of using a lossy algorithm for this purpose. Lossy, as opposed to lossless, means it loses some quality on compression. Also means that you cannot get the original back unless you've made a copy of it after compression. So I'm going to write for my answer that the quality will be lower. So my answer is the quality will be lower as some detail is lost on compression, and that completes question 4. Question 5. Programmers work as part of a team to develop software. They use truth tables to determine if an expression evaluates to true or false. Complete this truth table for the Boolean expression P and brackets Q or R. You may not need to use all rows. So here's our truth table, and I'm just going to zoom it out a bit just to see it a bit better. Now the thing to remember with something like this is you're getting marked by the column, not the row. So for all correct values in P, Q and R, you're going to get 1 mark. For correct values in Q or R, another mark. And for correct values in the final column, you're going to get your 3rd mark. So what we need to do is fill out column P and put in all the possible values of P, Q and R. So just simply started by placing 0s and 1s in column P. So what we're looking at now is P, Q and R filled out. And I've got all different combinations I can have. So 0, 0, 0 to start off with, and at the bottom 1, 1, 1. And then in between 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. That's all the possible combinations I've exhausted that we can have for P, Q, R in there. So that's going to give me a mark. Now I need to fill out the column that says Q or R. So what that means is either Q or R needs to be a 1 for Q or R to be a 1. So in the first instance it's a 0 because neither Q or R are 1. In the second instance it's a 1 because R is 1. In the third instance it's a 1 because Q is 1. In the fourth instance it's also a 1. But Q or R for this row here it's a 0, then a 1, 1, 1. So that's gained me an extra mark there. Now this final one, P and Q or R. So the first one, it's all zeros, so it's going to be a 0. P and Q or R, well P is 0, so that's going to be a 0, because remember with an and, both have to be a 1. P and Q or R, well P is 0 there, and it's also a 0 here because P is also 0. P and Q or R, now in this row, P is 1, but Q or R is 0, so that will also be a 0. In this row, P is 1 and Q or R is 1, so that will be a 1. And the same in this row and the same in this row. Now that completes the truth table for 3 marks. B, the team is working on software for a ride-on lawnmower. The lawnmower must not start unless it's safe for the driver. Brake B must be engaged, the driver's seat S sensor must be engaged, and the safety lock L must be removed. Construct a Boolean expression use and or not with the letters B, S and L to show the safe starting conditions. So we start with B, and that needs to be a capital B. So just going to place that there. Okay, so brake engaged and the seat sensor must also be engaged. Now we've also got to have another and. Now L must be removed. So what we need to do is invert that, and we need to say not L. So to invert L, because we want L to be off, we say not L. So the answer is B and S and not L. And that's 2 marks. C, the team uses code reviews as part of the software development process. Date 2 ways in which code reviews can protect software systems from cyber attacks. Well, what we're looking at is removing weaknesses from coding. So our answer needs to say removing coding vulnerabilities by using reviews, and we're also eliminating bad programming practices. Each programming language will have vulnerabilities in its language. So we are removing them by having coding reviews. So let's have a look at D for the last part of the question. The team needs to develop its intellectual property rights over systems that it develops. Give 3 types of protection the team could use. So there's actually 4 we can have here: copyright, patent, licensing and trademark. So I've gone for copyright protection, trademarking and licensing, which is the user needs to have a license to use the software. You could also have patent as well. And that completes question 5 for a total of 10 marks. Question 6. A software engineer is working with some algorithms. The algorithms need to be developed. The algorithm must check for a change of hour every minute, use the library subprogram getHour to get the hour part of the current time in the 24-hour clock 0 to 23, output good morning when the hours between 3 and 12 inclusive, output good afternoon when the hours between 13 and 19 inclusive, output good night at all other times. Complete the flowchart to represent this algorithm in the space provided. The call to the library subprogram getHour has already been included. Use this subprogram to show waiting for 1 minute. Wait. So we used start and we used getHour on the left hand side. And you can see now in this sample solution that we've got a decision diamond for the first bullet point. Is hour greater than or equal to 3 and hour less than or equal to 12? If yes, so it's morning, we output good morning. Then we go to our wait. Now you can see that that's a subroutine there that needs to be represented with the shape, a rectangle shape with 2 extra parallel lines down the side. Now the no needs to go to the next decision. Is hour greater than or equal to 13 and hour less than or equal to 19? Then yes, then output good afternoon. If no, then output good night, and we can see on both occasions from the output good afternoon and the output good night that we go back up to the wait 1 minute. So here is the full solution, and this is the full solution here. So there needs to be no errors in the logic, so it needs to be logical. You need to think it through carefully. Each bullet point needs to be done in turn, so this solution covers each bullet point. The notation follows a recognizable convention is applied consistently throughout. Now you must use the correct flowchart symbols. So in here we've used diamonds for the decision, which is only having 2 outputs, yes or no. For the output, we've used a parallelogram. To call a subroutine, we've used a rectangle with 2 parallel lines down either side. And also for another output, we've got the parallelogram. And there is no stop because we loop back to the beginning of this question. Specifically said it needs to loop back to getHour. So it needs to be checking the hour, the time regularly. And that is our solution. So remember, that is a total of 6 marks, and to get 6 marks you've got to be logical and you've got to use the correct flowchart notations. So we'll scroll through now to question B. Another algorithm determines when to change the flavoured syrups for drinks in a dispensing machine. Figure 4 shows the algorithm written in the pseudocode. So we've got set flavours to anise, mango, cola, apple, papaya, strawberry, lychee, banana. So that is an array. Underneath that in line 3 we've got volume, another array to set to 0.7, 0.2, etc. We've got a variable called I, which we set to 0, and while I is less than 8, do. Now, there are 8 flavours, so I is less than 8. And remember, array indexing starts at 0, so I was set to 0 for the index, so we set I to be 0. So we start with anise. Array indexing starts with 0. And while I is less than 8, well, it's less than 8 and not less than 9 because array indexing starts at 0. So 0, 1, 2, 3, 4, 5, 6, 7 is 8 values, with the 7th value being banana. If volume I is less than 0.1, then some flavors I needs changing to display. Else, volume I is greater than 0.3 and volume I is less than 0.5, then some flavors I needs ordering to display. End if set I to I plus 1, so it counts I there. So it increments to the next value. So we will look at the next value in the array, the next element in the array. So now we need to give the output produced by the algorithm for 2 marks. Now the first output is, we look at that, Okay, anise is 0.7. So we just look at our conditions there. So we're looking either less than 0.1. So if we go through that, we can see anise, mango, cola, apple there, and papaya. So apple is 0.1. It's not less than 0.1, but papaya is 0.05. So papaya needs changing. So our first output for 1 mark is that papaya needs changing. Now we look at the next one. If volume I is greater than 0.3 and volume I is less than 0.5, so we look at that condition now. So it's not 0.7, 0.2, no, 0.6, 0.1, 0.05, 0.8, 0.4. That's something we need to look at. And we need to say lychee, which is 0.4, needs ordering. So now for our next mark, we put lychee needs ordering. So now we look at the next question. The algorithm works with a fixed number of flavors. Give the number of the line on the algorithm that would need to be amended to allow any number of flavors. So if we look up here, number the algorithm. So in order to be able to add more flavors, we need to look at line 7 because it says while I is less than 8. And what we need to change that to is the length of flavors. So the answer for that is 7. It is line 7. And then obviously when you get a question like that, the next question, the logical question will be, how are you going to change it? So that's what we're getting in here. Number 3, how are you going to change it? Now, I would change this to while I is less than length of flavors minus 1 do. Why the minus 1? Because as we said, array indexing starts at 0. So if there were 8 elements in the array, we wouldn't want to go to 8. We'd want to go to 7, which would be actually the 8th element. 0, 1, 2, 3, 4, 5, 6, 7. So put length of the array 8 minus 1. So it goes from 0 to 7. And that is the answer for number 3. Now, this is the final question. The algorithms will be coded in a high-level language. Programs written in high-level language must be translated in order to be executed by a computer. Discuss the similarities and differences between a compiler and an interpreter. So first thing we need to do is discuss the compiler. So I'm going to go with the compiler. And it needs to be a discussion, but I'm going to make some points now. So I'm going to write down what it does, and then in my similarities, I'm going to have my discussion. So the compiler reads the whole file and translates it at once. What else does the compiler do? I'll just move that down there. Produces an executable file. The end user cannot see the source code. Another point is does not need the IDE to run code. So once you've created the executable file, you don't need to have whatever IDE, for example, idle, whatever it is, you created that in. You don't need to have that. Let's look at the interpreter now. So the interpreter is different in that it reads each line of code at a time. The source code is easily viewed. Because you're in the IDE, you can see the source code. It isn't an executable file, and you need the IDE to run the code. So you actually need to have idle to run the code, run the program. In Python, for example, if you coded it, you need to have idle. So now we've talked about that, let's go to the similarities and then we'll go to the differences. So similarities, both are high level interpreters. So they're not low level like machine code or assembler. Just going to move this down. Okay, so both high level, and what else can we say? Both produce machine code from a high level language. So your Python code has to be converted into machine code before the computer can understand it and run your program. What about the differences? Well, again, we're just picking out what we've written before. So compiler translates whole file at once. Make sure we spell it correctly. Whereas the interpreter reads each line at a time. What else can we say? Well, let's look at the fact that compiler creates separate executable file, whereas interpreter does not. Now, the compiled code does not need an IDE, unlike to be able to run interpreted code. So you don't need separate software. With the interpreter, you need to have idle to be able to run the program. But with compiled code, it creates an executable file. You just need a computer to be able to run an executable file. Just double click on the exe file and the program will run. Now that completes the paper from the 6 marks. And you've got to demonstrate comprehensive knowledge and understanding for this. It is worth creating a plan. Although I didn't do a plan for this question, perhaps for a 6 mark you might want to, if you're not sure what to write, you get a scrap piece of paper and start writing some notes on it before you construct an answer. But you've got to show a logical construction of answer. You've got to show that you've looked at the compiler and interpreter and then the similarities and differences and made sure it's logical, it flows well, you've used full sentences. You can use bullet points, but you've used full sentences there, and that it flows well and it's logical to be able to get 6 marks. Now, that completes the whole of the paper. So say again, a big thank you for watching. Please like and subscribe and comment below. Let me know how you got on. I always like hearing from you. It's always great to hear from you. Please comment below. Thanks for watching. Bye bye.